Okay, so here we go. So in the last time we met, we talked about the conditions to be able to do the inference for linear regression, right? And the acronym that we used was LINER, right? So let's quickly review this. L meaning
Linear.
it has to be a linear relationship, because if it's not linear, there's no point in actually doing a linear regression, right? What's the point, right? Independent, each separate thing has to be independent, correct? There's that. N was normal, E equal standard deviation, right? The standard deviation for every explanatory variable is going to have equal standard deviation. It's going to be normal. It's going to have the. It's not only is it going to be normal, but it's going to have equal standard deviation. R was, as always, it has to be. Okay, so these are the 5 things that you will check for in doing the inference. So today we're going to do the confidence interval, and then we're going to do the significance testing on the actual. We're going to do the confidence interval and both of those on the actual slope of your regression line. Okay, so that's what we're actually doing here. So the population, remember, looked like beta, not beta 1 x, and then the sample was y hat b naught plus b1, like that, right? Sure.
When you're doing the like problems in here, they do B. But I think they mean to use the other one. I don't know though, because I was confused on the homework. They use B, but the way they like did it, they seem to be using the one on top, so I didn't know.
Oh, okay. So we'll talk about that.
Okay.
We'll talk about that. Okay, so this is what we're doing. So we're going to use this. We're trying to find this, right? We're trying to do this. This is what we're trying to find. Okay, this is what we're trying to find. Okay, so let's go. We are on page 776, estimating the parameters. Okay, estimating the parameters. Okay, it says that this is going to be an unbiased estimator for this. Okay, we talked about that, but here's the thing. When we talked about the standard deviation, we actually said it was like this, right? Talked about that the other day, right? The actual, so this is going to be the standard deviation of the slope. Okay. The problem, and I kind of hinted at this, was that we do not know this. You do not know this, neither do we know this, really. Okay. So the way the book gets around this problem is in the middle of page 777, in the middle, the paragraph says, in practice, we don't know sigma for the true regression line. So we estimate it with the standard deviation of the residuals, which is S. We also don't know the standard deviation for this guy down here. This guy down here, we do not know that either. For the population of the X values. For reasons beyond the scope of this text, we replace the denominator with that. So basically what we're using is that the standard error for B1 is going to be equal to the standard error, not the standard error, the standard deviation up here. And then over here, it's going to be the standard deviation and square root of n minus 1. So in this one, you're supposed to just push the I believe button and move on. Okay? It says, it says that for reasons, what does it say, beyond the scope of this text. Okay, so here we go. So this is what you're supposed to use, okay? So this will actually be given to you most of the time in a readout. You will not usually have to drive this. Sometimes you might have to, but usually it's just going to be in the jump or the mini-tab result. Okay? So that's an example, the helicopter experiment, part 2. So let's go ahead and read that. Earlier, Mrs. Barnett's class used computer software to perform a least square regression analysis of their helicopter data. Recall that the data came from dropping 70 paper helicopters from various heights in inches and measuring the flight times in seconds. Some output from this regression analysis is shown here. We checked the conditions for performing inference earlier, so we're not gonna do the liner on this one. We already did that. A, what is the estimate for beta naught? So that would be B naught, right? So this is, we're going this versus this here, okay? All right, and that's actually in there where it says constant negative 0.03761. Okay, that is your B naught. Okay, interpret the value. If you flip, it says B is equal to that. It says if the helicopters drop from 0, it'll take that long. So it's the y-intercept, right? So how can the y-intercept be negative? So this is a quirk when you do regression analysis, right? Right? Because there's no way it's a negative value, right? You can't go negative, right? Because if you're dropping from here, this is 0. So that would mean you were dropping from here now, right? Okay, but that's just the way the analysis, regression analysis works when you do that, okay? Not all the time, but sometimes, right? Okay, so that's that. B, what is the estimate for beta 1? Beta 1 will be what? You have 0.00572444. That would be this guy right here, right? B1, that would be B1. Okay. C, what is the estimate for sigma? Okay, that would be your standard error coefficient there. It would be 0.0. No, that would be point for the, that would be the point, no, it's the S, correct, it's the S. 0.168181. Okay, the one that shows right there. So that's the sigma, this guy, the S versus the sigma. Okay, all right. D, give the standard error of the slope SEB1, and that is the 0.0002018. Okay, that would be that. Again, this is just strictly reading off of the data that's given. Okay. All right, so constructing a confidence interval of the slope. So we're actually going to construct a confidence interval, and the confidence interval is given as, it's going to be the B1, right? B1 plus or minus star. Okay. So what you really need, the only thing, so this is going to be given to you. This is going to be given to you. The only thing that you really have to find is this guy here. Okay. The quirk, or the difference in this one is that when you do the DF, degrees of freedom here, the degree of freedom is no longer n minus 1. The degree of freedom is n minus 2. Okay, so let's go to page 778, bottom. There's a green box. Read that. Okay, so it is, again, it's this, but it's going to be a degree of freedom with n minus 2 instead of n minus 1. Let's go ahead and do the example. How much is that truck worth? Okay, so we go back to the F-150s. Okay, remember this, where you were trying to figure out how much the truck was after you've driven it so many miles and that kind of good stuff. Okay, so there is the data, same data that we had before. Regression line gives you the residual plots. Flip the page, it actually gives you the readout, which is what you're gonna have to go with, right? So the question was, construct and interpret a 90% confidence interval for the slope of the population of the regression line. Okay, so we're looking at this guy right here. Okay, we're doing a 90% confidence interval. Okay. And then what? So what do you have to do? We have to do the line art here, right? Is it linear? Is the graph linear? Which one do I have to look at? No, I look at the regression line itself. I look at the data. I look at the data, right? Really? I'm looking at that to see if it's linear, right? So that would be the one on the left, right? And then independent, yeah, they're independent. Each one is independent. The trucks are not dependent on each other. A normal, what am I looking for normal? Which one tells me it's a normal? Okay, the histogram tells you, right? The histogram tells you, right? The histogram there. Histogram tells you there are no skewness. Right? It looks pretty somewhat symmetrical. Okay, I'll say somewhat symmetrical. All right. And then the equal standard deviations. What's that one?
Residual.
That's the residuals, right? If you look at the residuals, they're pretty evenly distributed, right? They're not, there's no pattern there again, right? There's no pattern to it. And then what's the last one? Random. Yeah, these are random samples. So yes, we're good to go. Okay, so let's go ahead now. Let's go ahead and construct the actual confidence interval. What is B1 from your readout? What is B1?
Is it 38257?
No. No. Okay, so we are. So it's going to be the negative. No. So negative 0.16292 is going to be what? That's the B1, correct? What is B naught? The 3/8. I don't know. We're not interested in that, right? We're not actually looking at that. We're looking at B1 here. So the B1 here is going to be negative 0.16292. Thank you. 292 plus or minus. I don't know what this is. What is this? The standard error. Standard error is 0.03096, right? 0.03096. I just need to find that guy. So let's go back to the bottom, the back of the book. It's T-3, right? T-3, 90% with a confidence interval of what? How many data points do we have? 16. There are 16 of them. 1, 2, 3, 4, 5, 6, 7, 8. So 16. So your degree of freedom would be 14. So if we look at 14, it is 1.761. 1.761. So this is going to be 1.761. Okay. And if you do that, you get negative 2.1744. Negative 21744 negative 0.10842. Okay. 40. Okay. All right. So let's go ahead and interpret this. We are 90% confident that the interval here to here contains the slope of the true regression line, correct? Okay, all right. So you actually have to do a little better on that, where it says on the slope. Okay, the book says captures the slope of the population regression line relating y is equal to the price to x equal miles driven for the Ford blah 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 blah.
Do you have to write down the relating y equals blah, blah, blah?
Yes. Because when it's a regression line, right, You have to, what you're actually doing there is what? You're actually telling the people what your explanatory variable and what your response variables are. Okay? You're actually outlining them now. Okay? All right. So on page 781, it tells you how to do this in your calculator. So it says that we will go to stat and tests. And then you'll look for the linear regression t-interval test. That's the test that you would use. Okay, obviously the L1 and L2 are the values that you put in there, right? So you're going to use L1 and L2 there, right there. Put in the confidence level and everything and blah, 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 calculate, and it's going to spit that stuff out.
Miles Joseph would be L1, right?
Mm-hmm. All right, so that's the first part of what we're going to do. So we'll go ahead and stop right here.